Unit 5.2, Inequalities in Triangles. Now we learned that if all three sides of a triangle are equal, we call that equilateral. And if a triangle is equilateral, then it's also equiangular. So if all the sides of a triangle are equal, then all of the angles are equal. And then we learned in an isosceles triangle, if two sides of a triangle are equal, then the angles opposite those two equal sides are equal. So if two sides of a triangle are equal, then two angles of that triangle are equal. So we've already learned some equalities for a triangle. But what if the sides are not equal or the angles are not equal? Well, there's still a relationship that exists inside those triangles. And what we're going to learn is that if we have a small, medium, and large side, then the angle that's opposite the largest side of the triangle is going to be the largest angle. And the angle opposite the medium-sized side of the triangle will be the medium-sized angle. And the angle opposite the smallest side of the triangle will be the smallest angle. Example, let me draw a triangle with a long side and a medium-sized side. Maybe I could be a little more discreet on my medium and small. And a medium-sized side and a smaller side, and I didn't color code that very well. But you can see that this angle that's opposite that larger blue side is the larger of the angles. And that angle that is opposite this medium red side is the medium angle. And the angle that's opposite that smallest black side is the smaller of the angles. Now, the geometry book definition, this is a geometry book, but the official definition says if the sides of a triangle are unequal from large to small, then the angles opposite those unequal sides are unequal in the same order, large, medium, small. If the sides of a triangle are unequal, then the angles opposite those unequal sides are unequal in the same order. That basically comes down to the fact that the angle opposite the largest side is the largest angle. The angle opposite the medium-sized side is the medium-sized angle. And the angle opposite the smallest side is the smallest angle. And that's the way I would like for you to memorize it, because that's the way you're going to use it. The other theorem says if the angles of a triangle are unequal, then the sides opposite those unequal angles are unequal in the same order. That's kind of complex. What we did here is we created a triangle that looks almost isosceles or almost equilateral, and so you really couldn't tell by looking which angle is bigger, A, B, or C, because they're so close to the same. But we could reach the conclusion that angle B is the larger of the angles because it's opposite the larger side, 8. And we could say that angle C is the medium size angle because it's opposite the medium size side of 7. And we could say that angle A is the smallest angle because it's opposite the smallest side of 6. So sometimes it's not going to be obvious with the eye which one is large, medium, small, so we're going to have to use the mathematical logic. Okay? So the angle opposite the larger side is the larger angle. The angle opposite the medium-sized side is the medium-sized angle, and the angle opposite the smallest side is the smallest angle. The converse of that is true. The side opposite the largest angle would be the largest side. The side opposite the largest angle would be the largest side. And the side opposite the medium size angle would be the medium size side. And the side opposite the smallest angle would be the smallest side. Again, it may be difficult in a diagram to tell visually which one is the smallest, and I probably should have made those 60.1 and 60 and 60 59.9, just made them a tenth of a hundredth of a degree. I'm sorry, a tenth of a degree apart. Be a little less obvious. But anyway, just looking at the numbers there, we can say AC, where is it at? Well, it's opposite the largest angle, so AC must be the largest. And BC is opposite the medium size angle, so it must be medium size side. And AB is opposite smallest angle 40, so it must be smallest side. Any questions on that? Theorem 5.3 says, to see if three lengths can form a triangle, small plus small must be greater than large. The fancy way of saying that theorem is, to be a triangle, the sum of the smaller two sides must be larger than the length of the third side. The sum of the smaller two sides must be larger than the length of the third side. The sum of the smaller two sides must be larger than the length of the third side. If it's not a triangle. Let me show you why. If you were going to try to draw a triangle, I've got to get my writing instrument back. Let me hit the highlighter and then the pointer, and then it'll start working again. So let's say that I had a segment of length such and such, it doesn't matter. And I take a length that would go to here. If I opened up my compass, right, with the little compass thingy, and I made an arc, then I could basically make an arc like that. And then if I opened up my compass to here, and I opened up, it would make an arc. If this length plus this length added together is not more than that, they're never going to hit at a point above the red so that it can make a triangle. This is just going to spin around, and this is going to spin around. If we wanted to get a triangle, we would have to take something so that this arced and this side arced would hit at a point above the red, and then we could connect and get a triangle. For that to happen, the blue and the green have to add up to more than the red. The sum of the smaller two sides must be greater than the larger side, or it's going to spin around, spin around, spin around, never make a triangle. Okay? All right, example. Could 2, 3, and 6 be the measures of the lengths of the sides of a triangle? Well, to see if that could be a triangle, you add up the smaller 2. What's 2 plus 3? And we're going to compare that to 6. 2 plus 3 is not greater than 6. It's less than 6, so this cannot be a triangle. What about this set of data? Could 2, 3, and 4 be the sides of a triangle? Well, to check it out, we add up the smaller 2. 2 plus 3. Compare it to the larger. The sum of the smaller 2 is greater than the larger. Small plus small is greater than large. So yes, these numbers could be the sides of a triangle. 2 plus 3 was greater than 4. Therefore, yes, it could be a triangle. What about 2, 3, and 5? We're going to try out 2, 3, and 5. Again, what we want to do is see if the sum of the smaller 2 is greater than the larger. So we take the smaller 2, 2 plus 3, compare it to the larger 5. 2 plus 3 is 5. Is 5 greater than 5? No. So the sum of the smaller 2 is not greater than the third. So this is not a triangle. We should already know that 2, 2, 2 is a triangle because it's going to be an equilateral triangle. But we're going to show you that it's going to work anyway. If we took the sum of the smaller 2, pick any 2, and compare it to the other one, then the sum of those 2 would be greater than the third. The sum of the 2 smaller, or 2 of those, would be greater than the other. So yes, that is a triangle. It's an equilateral triangle. All the sides are the same. Any questions on this lesson on inequalities in a triangle? Well, that brings us to the daily work, which we'll just continue the recording for. So daily work unit 5.2. We want the largest angle. Well, how are we going to find the largest angle? We're going to look opposite the largest side. Now, to compare these, we need to find a common denominator or change them to decimals. A common denominator would be eighths, and so a half would be 6 and 4/8. A fourth would be 6 and 2/8. So what's the largest? Well, the 4/8 is the largest. So this is the largest side. Therefore, the angle opposite is the largest angle. So the largest angle is angle C. And you can complete that. Finding common denominators is on page 8 of the Algebra 1 textbook. If you need to look at finding common denominators and making equivalent fractions. The next one's the largest side. The largest side is opposite the largest angle, but we don't know all of the angle measures. But what we do know is that the sum of the angles of a triangle is 180. And we can add those two up and see that they add up to 110. So 180 minus 110 would leave 70. And so we know that the angle at is 70 degrees. We're looking for the largest side. It's going to be opposite the largest angle. The largest angle is 70. And so the largest side is going to be what's opposite it. And what's opposite it is DE. And so the largest side would be side DE. It's very important in geometry, obviously, to be able to identify the side opposite a certain angle or the angle opposite a certain side. Identifying sides opposite or sides adjacent is important. We'll look at that more when we get into chapter 6. And there you could, on your own, identify the medium and the small. Now, this is a little bit complicated. The overall largest side. Number 7, the overall largest side. Well, we know that the sum of the angles of a triangle is 180, so this is going to be 60 degrees over here on the right. And the sum of the angles of a triangle is 180, so this is the 70 degrees on the left. Now, we know that in the triangle on the left, the largest side is GH. It is the largest side of the triangle on the left. We know that HJ is the largest side of the triangle on the right. Now, HJ is the largest side of the triangle on the right because it's opposite the largest angle line. And I've color-coded the blue side opposite the blue angle. And we know that GH is the largest side of the triangle on the left because it's opposite the biggest angle of the triangle on the left. And so HJ is larger than HI and JI, so they're out. So according to the triangle on the right, HJ is the biggest. But in the triangle on the left, GH is biggest, which means that it's even bigger than the largest of the right. So HI is out and GI is out. So the largest overall is GH. That's a little more complicated when you attach two triangles together. We're going to let you play with number 8. Write out an explanation of what your conclusion is. Maybe you can't even reach a conclusion. Your conclusion may be, I can't reach a conclusion. But don't choose that option first. That might be lazy, just to say, oh, I'm just going to choose that and I don't have to think. Because there could be a conclusion. So there might be a conclusion. There might not be a conclusion. You need to study and dig and see if you can figure that out. Obviously, looking at the triangle on the left, this is the largest side, so angle A is the largest angle of the triangle on the left, right? And we could go to the triangle on the right and say, well, the largest side is, therefore we can conclude the largest angle is. So we know the largest angle of the triangle on the left is A, and the largest angle of the triangle on the right is C. Is there any way to know if A is greater than C? Is there any way to know that angle A is less than C? Is there any way to know that angle A is equal to angle C? As of right now, can we prove any of that? And down the road, is there a possibility to prove something? That's for you to think about. Write out an explanation and let your teacher explain. Can we conclude it now? If not, can we conclude it later? Something to think about. All right, number 9. Tell whether the following links can form a triangle. So what we're going to do here is we're going to take small plus small, and we're going to compare it to large. Now, so there's going to be one that's bigger than the other two. That's this one, obviously. And so we're going to compare the sum of the smaller two to the larger. Now, we know to be a triangle that the sum of the smaller two has to come out to be greater than the larger, but we don't know that yet. That's what we're wanting to happen if we want it to be a triangle. So we're going to add these. We would get 5.7, and this is 5.57. And we know to actually compare, we would add a decimal, and 0.70 is more than 0.57. And so the one on the sum of the smaller is greater than the larger. Therefore, yes, it is a triangle. Okay? And I've created this to where you're going to have to mess with some fractions and some decimals and find common denominators to change. Since this is a decimal, to change a fraction to a decimal, you divide 1, divide 4. That's how you'd punch that 1/4 in the calculator, and it would turn it into 2.25. Right here, you would line those up and find a common denominator. The common denominator is the least common multiple. It teaches you how to do that on page 8 of the Algebra 1 text. You need to know how to do that on paper, not just on the calculator. Use the diagram and a protractor to reach conclusions. And so here again, you're making these measurements, you're reaching conclusions. Your conclusion will be the rule on the next page, the next lesson's rule, so you could look to the next page and find out how to fill in these blanks right here. But we want you to use your measuring devices to draw measure accurately. It'll give you a visual of the next lesson. When you go to lesson 5.3, you will find the answers for that discovery learning at the end of the daily work on unit 5.2.